Today we're going to be learning about the decomposition of forces and how these can be applied in like problems in mechanical engineering. So let's just get started. So first thing that you should know before doing this is the basics of trig. A lot of the time for mechanical engineering classes, you're going to have a calculator on you, which are going to be nice, very helpful, very, very helpful. But in general, you have to at least know SOHCAHTOA. SOHCAHTOA is the basis for decomposing forces. If you don't know SOHCAHTOA, that's not very good, is it? So yeah, you should learn SOHCAHTOA, or freshen up on trig. If you're really struggling with it, there are tons of resources, Khan Academy, Organic Chemistry Tutor, a lot of good resources. But let's just start off with a simple conceptual problem. So let's say you have a pole, okay? It just boom, and it's acting on the ground, it's on the ground, okay? This force is called F, okay? Now, this force is acting diagonally down, okay? How do we know what's up and down? Well, in ME and mechanical engineering, okay, we're going to want to make a coordinate system. So you're going to have, I'll just draw it out and explain it. So, what does this mean? Basically, any forces moving this way are positive. I didn't draw that positive large enough, which is on me. So any forces moving this way to the right are positive, okay? Any forces moving up, moving, positively on the y-axis, which is given here, which is why this is positive, okay? So if something were to act to the left, that's acting negatively because it's going against the coordinate system, okay? And if it's acting downwards, it's acting negatively, okay? So this force right here, it's acting positively in the x direction because it's moving to the right. It's acting negatively in the y direction. Can you kind of understand that? So let's think about this in terms of how to decompose this force. What does it mean to decompose a force? Well, you have to think about triangles, which is why I'm saying get back to trig. If you have a triangle, okay? You have a right triangle specifically. Say this is angle theta, and this is angle alpha. So let's say we have our hypotenuse and two legs. So we'll call this one A, this one B, this one C. So we have this triangle, right? What if we only had C? We know what C is, right? We know what this is. But we need to know what A and B are. We don't know these. Let's find them using these angles, okay? So let's say we wanted to find A. We can use trig, right? This is just the basic of trig. So we can find angle adjacent to alpha is A. So we can use the ka in SOHCAHTOA to find that cosine of alpha is equal to C, which is the A over C, okay? But we can also rewrite this, just move this over, multiply both sides by C, and we can find that C times cosine of alpha equals A, right? And if we wanted to find B, we can kind of apply the same thing. Opposite over hypotenuse. So sine of alpha equals b over c. And we can rewrite this as c times sine of alpha equals b. Right? This is just algebra. It's multiplying, moving things to the side. Now with theta, if you want to find a using c, a is opposite theta. So to find that using c, we have to do sine of theta equals the opposite over the hypotenuse, so a over c, and then we can bring the c around. Yeah, c times sine theta equals it. And we can do the same thing with theta to find b. B is adjacent to theta. Okay, so we'll come back here. So cosine theta is equal to the adjacent over the hypotenuse, or b over c, and we can rewrite that again as c times the cosine of theta equals to b. Okay? So this is just kind of like a trig review, okay? And why are we learning this? Because this can be done exactly to f. So f is acting diagonally, meaning it's going down and it's going to the right. So let's draw f again, separated from everything else. And let's draw the y component and the x component. As you can see, we're a triangle. Okay? And we'll call this angle here theta. Okay? And this angle here would also be theta. So we can find these two things. This would be the x component of the f, because this is along the x plane. So we can call this fx. And then we have the y component, which is going straight down. It's along the y-axis, right? So you have f. Ooh, that is very big. So we have fy. So we're going to do the exact same thing using SOHCAHTOA. So to find fy, we'll use our angle theta. These are the only two things we know. We only know theta and f. Okay? So let's start it. So sine of theta, let me write this way here. Sine of theta will give us what? The opposite over the hypotenuse. The opposite of theta is fx over the hypotenuse, which is f. Right? And again, we're going to use algebra. We're going to bring the f over here. So that f times sine of theta equal to fx. And just like that, we have decomposed the x direction. We found what the x direction, like this force's x is. The x component of this force. Let's find the y. So we're going to use the same thing. We only know the angle and f. Okay? So we're going to use cosine. Cosine because theta is adjacent to fy, or fy. So cosine theta is equal to fy over f, because again, adjacent over the hypotenuse. and we can use algebra, multiply both sides by f, and we'll get f equals, my apologies. We'll get f times cosine theta equals f y. And just like that, we found the x and the y component of f. Now, if we actually knew these things, we can compute it. We can find real numbers for these things. So let's do that. Let's find a real forces f and y components. So let's say that this force is acting at a 60-degree angle, okay? And that this force is a 300 kilonewton force. Decompose this force into its f and x, to its y and x components. If you'd like to take a try at this, go for it. If not, we'll just learn through it together. So let's get started. So we can try the triangle, and I suggest that you do when you're starting to learn this. So let's try it. So this force is again acting down to the right, meaning that this is down and this is that way. Okay, and that this is our 300 kilonewtons. Okay, and this is our unknown x component. We'll call this fx again, and we'll call this fy. And we know that this angle is 60 degrees. Okay? So let's solve. So Katoa, let's find fx first. Find the opposite, right? So we're gonna go sine of 60 equals the opposite, which is fx, over the hypotenuse, which is 300. We'll bring the 300 over here. So 300 times sine of 60 equals fx. And let's solve for the y. We'll use cosine because the adjacent of 60 degrees is fy. So cosine of 60 is equal to our fy, our adjacent over our hypotenuse. Our hypotenuse is 300, and we're going to use algebra again. 300 times cosine 60 equals fy. And to solve this with real numbers, we're going to use our trusty dusty TI-84. 300 times sine 60, of course, in degree mode, because we're not using radians, we're using degrees, that means that we have a x component that is equal to 259.807, which is 81 kilonewtons. Fy, 300 times cosine of 60 is 150 kilonewtons flat. And that is how you decompose a force. Let's do another example. So try this one for yourself. This is acting 45 degrees, and there's a 30 pound force. So try it out. Decompose it into the x and y components. If you can't get it, come back here. So again, we're gonna do this a little bit slowly, but with time, you'll get faster at this. Just to practice. So sine of 45, okay, equals to, what is it equal to? Fy over 30. I didn't draw it out, but you can kind of imagine in your head, or if it helps you, you can draw it out yourself. If you think about it, there's a y component, there's an x component over here, and there is a y component on this side. Oh, we're going to study over here. 30 times sine 45 equals Fy. We're using sine to find our Fy because it is opposite of the 45 degree angle. This is Fy, this is Fx. Now cosine 45 will get us our Fx over 30. So 30 times cosine of 45 equals Fx. And we can just solve these. But as you'll soon figure out, or maybe as you know, if you know trig pretty well, we get this force Fy to be 21.21, and we get this force to also be Fx equals, I don't have to put it in my calculator, but I will double check, especially with teach people. It is the same exact number. Why is it the exact same number? It's the exact same number. Oh, sorry. Important thing. Units. Don't forget your units. The exact same number because a 45 degree triangle, these legs are the same. If this is 45 degrees, and this is 90, this also must be 45 degrees, meaning that these two are the exact same. So that's a neat little trick you can kind of use. And that concludes it for today's lesson. I hope you learned something. If this is new to you, I hope you learned some new concepts. If there's any questions that you have at all, please let me know in the comments or email me. It's in my YouTube channel information. I'll leave it in the description below as well. Thank you for watching.